Hi students, welcome to physics classes. Today we'll discuss vectors. Vectors. Physical quantities means quantities which are measurable are known as physical quantities. Quantities which are measurable are known as physical quantities. Now these physical quantities based on the direction and magnitude are divided into two types: scalars and vectors. Scalars and vectors. Scalars means quantities, physical quantities which has only magnitude. Which has only magnitude are known as scalars. Physical quantities which has only magnitude are known as scalars. Example: distance, speed, time, mass, temperature. Like these all are having only magnitude. These are known as scalars. Now vectors means physical quantities which has both magnitude and direction. Both magnitude and direction. Physical quantities which has both magnitude and direction. With these two, it should obey laws of vector addition. Laws of vector addition. Vector should not be added like scalars. Okay, they are having some rules that we will come to know in the next classes. They should have both magnitude and direction, and as well as it should obey laws of vector addition. Then those quantities are known as vectors. Example: displacement, velocity, acceleration are vector quantities. Acceleration are vector quantities. Now a vector is moving from A to B in this direction, so it can be represented AB bar like this. AB bar with arrowhead. Arrow indicates direction, length of the line segment indicates magnitude. If it is moving B to A, it is also measured BA like this. Arrow always should be shown like this, and it should not be like this. This is absolutely wrong. Always like this: B to A, A to B, B to A, based on the direction. Okay, once again, scalars which has only magnitude and vectors has both magnitude and direction, as well as it should obey law of vector addition. Now one example we will take: electric current. Electric current has both magnitude and direction, and it is a scalar quantity because it is not obeying law of vector addition. For example, if a current A to O and another current B to O, and it is going like this. like junction law. According to junction law, here for example, if it is I1, if it is I2, this is I. According to junction law, we can write I equal to I1 plus I2, like normal addition. But vector addition should not be like this. If it is a vector, it should be like I equal to square root of I1 plus I2 plus 2I1 I2 cos theta. Parallelogram law. Parallelogram law of vector addition. It should be like this. So electric current is a scalar quantity. Why? Because it is like this. Okay. Now here we see in vector. If a vector A to B, it has both magnitude and direction. Both magnitude and direction. To represent only magnitude, it should be take like this. Modulus of AB bar means magnitude of AB. Magnitude of AB. For example, if a vector A bar, only A bar, to take its magnitude, A bar modulus means magnitude of A. Magnitude of A. Like this we have to take. Now types of vectors. Types of vectors. Vectors we have different types. Now we'll discuss types of vector. And the first one is equal vectors. Equal vectors. Equal vectors means if two vectors have same magnitude and direction. Two vectors has same magnitude. This is one vector, this is another vector. Now these both are having same magnitude. Magnitude means length of the line segment. And the arrowhead indicates direction. Arrow indicates direction. If two vectors A bar, B bar has same magnitude and direction, same magnitude and direction, then it is equal vectors. Now we can write here A bar equal to B bar. A bar equal to B bar. Two vectors have same magnitude and direction, then they are equal vectors. Next one, like vectors. If two vectors have same direction, direction is same. Now this is vector A bar. Now this is vector B bar. Both are having same direction, but magnitude is different. Magnitude is different. Same direction, different magnitude. Those vectors are said to be like vectors. Those vectors are like vectors. Now here we can take B bar is exactly half of the A bar length. Length of the B bar is half in the A bar. So we can write A bar is equal to 2B bar. Vector A equal to 2 into vector B. So two vectors have same magnitude but different direction. Same direction. If two vectors have same direction but different magnitude. Those vectors is said to be like vectors. Like vectors is also known as parallel vectors. Like vectors is also known as parallel vectors. Parallel vectors. Next one, unlike vectors. If two vectors A bar and B bar have opposite direction and different magnitude then these vectors are said to be unlike vectors. Opposite direction, different magnitude. Now if B bar is half in the A bar, like previous example, don't think that exactly half. It may be half or more than half, less than half or more than A bar also. Okay, just example purpose I have taken. Now A bar is equal to minus 2B bar. Minus indicates opposite direction. Minus indicates opposite direction. So these vectors is known as unlike vectors, and those are moving in opposite direction, anti-parallel vectors. Anti-parallel vectors. Okay. Now next one, negative vector. Negative vector. Name itself it is showing negative. So two vectors have same magnitude, opposite direction. Two vectors having same magnitude and opposite direction, but opposite in the direction. A bar vector is going like this, B bar vector is going in opposite direction. So they are having same magnitude. A bar is equal to minus B bar, or B bar is equal to minus A bar. One is taken as plus, then opposite one is minus. This is negative vector. Next one, unit vector. Next one, unit vector. Name itself unit vector. Now a vector is having unit magnitude. Magnitude is unit. Unit means 1. 1 magnitude. Unit means 1. A vector is having unit magnitude. Then it is called unit vector. Vector is having unit magnitude, then it is called unit vector. Now if A bar is a vector, its unit vector is A cap. Is unit vector. A cap is unit vector. Cap symbol. Now unit vector is having magnitude is unit. As it is a vector, it should have magnitude and direction. Now magnitude is unit. Then what about direction? Is parallel to A bar, same as A bar, same direction. Okay, so now we can write A cap unit vector equal to vector divided by its magnitude. This vector is having both direction and magnitude. Here only magnitude cancel, 1 and direction equal to unit vector. So vector equal to magnitude and direction. Magnitude of a vector into unit vector. So if you have a unit vector, magnitude of a vector means a scalar. To convert it into a vector, we should add the direction. So multiplied with the direction, magnitude and direction, then it becomes a vector. Now unit vector has direction parallel to its vector A bar. Parallel to A bar. Okay. Now see here one note. We have two vectors A bar and B bar. Now another vector, a vector parallel to A bar, new vector, and its direction is parallel to A bar and magnitude is same as B. Now a note, like a problem. In the question they asked, find the vector whose direction is parallel to a bar and magnitude is same as that of b bar, then find that vector. Parallel to a bar, magnitude is same as b bar. So parallel to a bar means direction a cap and magnitude is equal to b bar. So magnitude of b bar. Then that vector is, we can find by using magnitude of b bar into unit vector of a. Magnitude of b into unit vector of a. Like this we can find the given vector. Next one, zero vector. Next one is zero vector. A vector has zero magnitude. If a vector is having zero magnitude, it is known as zero vector or null vector. Previously we seen unit magnitude. If magnitude is 1, unit vector. If magnitude is 0, zero vector or null vector. Null vector or zero vector can be denoted by O bar. Now for zero vector, initial point means starting point, terminal point means ending point, both coincides. So starting point, ending point is same for zero vector. Then what is its direction? Direction of zero vector or null vector is indeterminate. Direction is indeterminate. Okay, so we can't find its direction. We can't find, indeterminate. Now if you take velocity of a vertically projected body, initially u. Now at maximum height, now what is the velocity? What is the velocity of a vertically projected body at maximum point, maximum height, at the highest point is 0. Then it is determined by, it can be denoted by, explained by zero vector or null vector. Now null vector or zero vectors have some properties. Now if a vector a bar is added to null vector, results itself same. Another one, if a vector a bar and b bar is added to null vector, gives a bar plus b bar. Suppose two vectors, one vector is subtracted by itself, gives null vector or zero vector. If you product a vector with null vector, gives null vector. Okay, now zero magnitude is known as zero vector. If a vector has non-zero magnitude, if a vector has non-zero magnitude, then it is a proper vector. Some magnitude is there, that is not equal to 0. So we can write for example a vector a, its magnitude is not equal to 0. then this vector A bar is a proper vector. A bar is a proper vector. Now, if vectors are in the same plane, now this box is a plane. This box is a plane. Now, in the plane, same plane, A, B, C, D vectors are there. So, A bar, B bar, C bar, and D bar are known as coplanar vectors. If not in the same plane, acting in different planes, not in the same plane and acting in different planes are known as non-coplanar vectors. Next one is orthogonal vectors. Orthogonal vectors means angle between two vectors is 90 degrees. Angle between two vectors, any two vectors is 90 degrees, then those vectors are known as orthogonal vectors. Orthogonal unit vectors. Now, we know about Cartesian coordinate system. X-axis, y-axis, z-axis. Three are mutually perpendicular to each other. X-axis, y-axis, z-axis. Mutually perpendicular to each other. Now, unit vectors along x-axis is I cap. Unit vectors along y-axis is j cap. Unit vector along z-axis is k cap. I, j, k are unit vectors of x, y, z. Okay. Now, this I can be written as unit vector of I. Already we know about unit vectors. So, x vector x by magnitude of x. So, x vector equal to magnitude of x into I cap. Magnitude of x into I cap. Like that, vector y equal to magnitude of vector into j cap. Vector z equal to magnitude of z into k cap. Now, these three are perpendicular to each other. Between unit vector I and j, 90 degrees. J and k, 90 degrees. K and I, 90 degrees. So these three are known as orthogonal unit vectors. Okay. Now, here, for example, if a vector is having magnitude 3 units along positive x-axis. So it can be written as 3I cap. Now, if a vector magnitude is 9 units along negative x-axis, so it can be represented as minus 9I cap. Okay, like that we'll have j, k also. If it is represented along y-axis, magnitude into j. Represented along z-axis, magnitude into k. Okay, this is about orthogonal vectors. Next, position vector. Next one is position vector. A vector which specifies the position of a point, with respect to a fixed point like origin, is known as position vector. Now, x, y, z axis their unit vectors are I cap, j cap, k cap. Now, if you take a point, any point P on the coordinate system x, y, z. Okay, its position with respect to origin, with its position with respect to origin, position of P with respect to origin O is OP vector equal to xi yj zk, xi cap plus yj cap plus zk cap is the position vector, Now here I, j, k are unit vectors along x-axis, y-axis, z-axis respectively. Now here to determine its magnitude of OP, square root of x square plus y square plus z square. This is the magnitude of OP. Okay. Next, displacement vector. Now xy is a plane, x-axis, y-axis. Now O is the origin. Along x-axis unit vector is I cap, y-axis unit vector is j cap, that already we know. Now there is a point P in the plane xy plane. Now point P coordinates are x1 comma y1, with reference to origin its position vector is r1, r1 bar. So we can write r1 bar equal to x1 I cap plus y1 j cap, x1 I cap plus y1 j cap. Now another point Q, then these coordinates are x2 y2. Like our position with respect to origin is r2. So r2 e bar equal to x2 I cap plus y2 j cap. These two are position vectors. Now the displacement vector. Is the difference between 2 points. This is displacement vector, delta r bar. This is the displacement vector. This displacement vector is the differences between 2 points. So we can write delta r bar equal to r2 vector minus r1 vector, So that is equal to, we can write x2 minus x1 into I cap plus y2 minus y1 into j cap. This is the displacement vector. Now note. Now if a vector is multiplied with scalar, we will get result is a vector. When a vector is multiplied with a scalar, we will get result is a vector. So if a bar equal to s is a scalar into b bar, so scalar is multiplied with a vector, we will get a vector. Now this s is a scalar. Now if this scalar is positive, if s is a positive scalar, then A has direction is same that of B. A and B have same direction. A bar vector, B bar vector has same direction. If that S is negative scalar, so then minus A bar is equal to minus B bar. Then A bar and B bar opposite direction. A bar is opposite to the direction of B bar. A bar has direction that is opposite to the B bar. Okay, now we will see some properties. Vector obeys commutative law, commutative property. If S A bar equal to A bar S, where S is a scalar. S is a scalar. Next, this is multiplication. Next, it obeys associative law. Associative. During multiplication, vector multiplication obeys commutative law, and vector multiplication obeys associative law. When it is multiplied with scalar, S is a scalar. Now, n into A bar into M is equal to M n A bar. M n A bar. So M comma n are scalars. M n are scalars. Now distributive law. Vector multiplication obeys distributive law when it is multiplied with scalars. S into A bar plus B bar equal to S into A bar plus S into B bar. Here S is a scalar. Okay. This is about vectors and types of vectors and some important rules and properties of vectors. Thank you for watching. Please subscribe.